So moving forward to the activity 1, which is star connected source with star connected R loads. So this is the star connected source and this is the star connected R loads. So if you can see table 6.1, which is load measurement results Y connected R with 100 ohm. So we have 45 volt, 90 volt and 135 volt, which is this is the value of LV transformer voltage or phase, or we can say that this is the value of manipulated. Okay, so from here we need to find VRN in volt, VRY in volt, IRN in ampere, and P in watt and Q in var. So this is our circuit simulation. So from here, this is the V3 phase. So the amplitude we start with 45 volt, and then for the second is 90 volt, and the last one is 135 volt. So amplitude mode we choose RMS, and frequency is 50 Hertz. Okay, and then next one is wattmeter. This is have 2 wattmeter here, so we need to total up to find the sum of power. And then this is the AC voltmeter, which is VRY, and then this is the AC ammeter, which is IRN, and then we have 3 resistor here with same value 100 ohm, and then here we have AC voltmeter, which is VRN. Okay, so first we start this experiment with 45 volt. So after we run, first we look at the value of VRN. So we got VRN is 45 volt, and then VRY is 77.4 volt, and then IRN is 0.45 ampere, and then first wattmeter is 30.3 and second is 30.4. Okay, so we put all the value in table, which is VRN, VRY, IRN, P, and Q. Oh, sorry. For Q, we need to change this wattmeter. So we change the display range with var, and okay for both. And then after we run, we got value of var. First var is plus 17.5 and the next is negative 17.6. So after we total up, we will get 0. So we put 0 here. Same goes to the 90 volt and 135 volt. Okay, so after that, we just need to change the value of amplitude here with 90 and 135. So for VRN, we got 90 volt, and then VRY, we got 155 volt. IRN is 0.90 ampere, and then for first var is positive 70.0, and second var is negative 0.2, so we considering is 0, and then we need to change it back to the watt to get value of P. So we got first watt is 121 and second is 122. Next, we change it back to 135. And then we got value of VRN is 135 volt, VRY is 232 volt, IRN is 1.35 ampere, and wattmeter here 273 and 274. Okay, so we put all the values here. So if we want to make sure our value is correct, so we just need to compare with the calculated with formula. So for get the VRN, we just need to put value of source, and then for VRY, value of source we will times with set 3, and then IRN, value of source will divide with 100, and then for P we will use this formula, and also for Q. So that's all. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. So now I'm going to demonstrate how to do activity 2, lab 6, which is star connected source with delta connected RL load. And here is the circuit. And as you can see, the source part is connected in Y, meanwhile the RL load part is connected in delta. Okay, for this experiment, we're going to measure VRY, which is phase voltage, IRR, which is line current, IRY, which is phase current, active power and reactive power. Okay, here is my circuit. In this simulation, I will be using MATLAB Simulink. And for this circuit, I will be using 3-phase programmable voltage source, 3-phase transformer inductance, metric type with 2 winding, and 300 ohm resistance, which is connected in delta. So this is for measurement. This to measure V source. Ni to measure V source line to line. And this is to measure power, active and reactive power. And this is to measure V phase. This for current line. And this is for current phase. So now let's start with 45 voltage. So now let's set up our circuit. So for voltage source, I will be using 415 VRMS and 50 Hz. Okay, for transformer, we connected in Y for winding 1 and winding 2. And for parameter, the HV part, I'm going to use 415, and LV part, I'm going to use 45 volt. Okay, now let's run. Okay, now as you can see our active and reactive power, and here is our voltage phase, and here is our current line, and here is our current phase. So now let's move to 90 volt. So I'm going to change here to 90. Okay, now let's run. Okay, now you can see our active and reactive power, voltage phase, current line, and current phase. So now let's move to 135. Apply. Okay, now let's run. Okay, done. Here is our active and reactive power, V phase, current line, and current phase. So now I'm going to put all the data in this table, as you can see here. Okay, thank you.
Based on activity 3, this is connection diagram for star-connected sources with star-connected RL load. From here, we need to find the VRN for 55 volt, 90 volt, and 135 volt, VRY, IRN, P, and Q. Firstly, we need to connect all the components based on the circuit diagram. Firstly, we have voltage sources for V3 phase, and then we have wattmeter, we have AC voltmeter, AC ammeter, resistor with 100 ohm, inductor with 12.5 milli, and AC voltmeter. Firstly, we try to run the V3 with the 55 volt and 50 Hz, and we run. So the output here is watt is 14.9 watt and 15.4 watt, and so we total up it and we get the power. And the VRN we get 38.9 volt, VRY we get 78.5, and IRN we get 0.39 ampere. While for the Q, we change the unit for var. So the total here, we add the total here, so we get the Q value. Next, we try with 90 volt. And then we change to what? To find the value of P. Then we run. So here is the value. The first watt is 59.6 watt and 63 watt. So we total up it, we get the power. And the VRN is we get 78.5. The VRY we get 155 volt. And the current we get 0.78. Same goes to the Q. So this total we total up and we get the Q value. And we try with 135 volt. So the value here, the Q, for the Q we get, we total up the value of 2 wattmeter and we get the Q value. And the VRM we get 116 volt, VRY we get 234 volt, and the current we get 1.16 ampere. Same goes to the value of the power. We total up the 2 wattmeter with the unit watt, so we get the P. So the result simulation is same as the table from here.